Okay, we're going to be reviewing some factoring. I'm going to start off with some basic examples. We have a couple trinomials and then a binomial. And a lot of you may think of this as unfoiling, if you remember a process from algebra that a lot of you called foiling. Doesn't have to be called that. Multiplying, binomials, trinomials, things like that. So what we want to do is we want to end up with two parentheses that we can multiply to get back to p squared plus 13p plus 30. So when you look at the term FOIL, the F stands for first, and I'm going to start with that. How do I actually get p squared? It has to come from multiplying the first two terms together, whatever I put in my first positions in both parentheses. So the only way to get p squared or x squared or whatever your variable is multiply it by itself. So I'm going to have a p times a p giving me p squared. Then I'm going to go to the last, which would be the 30 over here. And I have to get a 30 by multiplying the two numbers that would be in the end of my parentheses, and there's just going to be a sign in the middle. Okay? Now, there's a couple ways to get 30. So I'm going to do a little bit of brainstorming over here. I know 3 times 10 gives me 30. I know that 5 times 6 gives me 30, 15 times 2, and we could go 30 times 1. So numbers that multiply to get 30 are listed, but here's how I'm going to pick. I've got to pay attention to this 13. And if you remember from foiling, that's your middle term. You have to add to get the middle term. Okay, now usually we have to be careful of signs. In this case, they're all going to be positive. So I'm simply going to add the 3 and the 10, and I get 13. 5 plus 6 gives me 11. 15 plus 2 gives me 17. 30 plus 1 gives me 31. Now, of course, I'm picking the one that matches up with my middle term right here. And that would be the first one in this case. So I wouldn't normally do all this work, but maybe you didn't think of the 3 and the 10 first. It just happened to be what I wrote down first. And then that tells me that, hey, I'm going to put a 3 and a 10 right there. Okay? Now your signs are going to be a plus and a plus right here because I need a positive 30. They could both be negative, but that would end up with a negative sign right here, and we have a positive there. So if you do have a negative at the beginning, or a minus sign, that would be why. And real quick, just to show you, I'm going to go ahead and multiply that back through, and we should end up right with our answer that we, just move that down a little bit. We're going to end up with the problem that we started with. So if I were given this problem right here and told to multiply the binomials, or do a process we called foiling, here's what I would do. I would do p times p giving me p squared. I would do outer p times 10, inner 3p, last 3 times 10, giving me 30. And notice that the middle two terms are like terms, and therefore they can be combined. 10p plus 3p is 13p, p squared plus 13p plus 30. That is exactly what we started with at the beginning, our problem. So you should always be able to to check your work just by multiplying back through. Okay, I went through that one in a bit of detail. Let's go through the others a little bit quicker. I'm going to erase my check here. And I guess I really don't need my multiplying. Clean this up a little bit. I am on to number 3. Taking a look, similar. This time I do have a subtraction sign at the end. We'll be careful of that as we go through it. Start with my two parentheses. I have a k squared at the beginning. Notice there's a 1 in front of the k squared. K times k gives me 1k squared. I need two numbers that multiply to get a negative 12 and add to get 4. So if you want to make a little chart over here, negative 12, that's multiplying. Add this time to get a 4. So I'm just listing numbers that give me 12, 3 and 4. What else do I have? I've got 6 and 2. I've got 12 and 1 if I'm listing them out. Okay, this time I need negative 12. That means one has to be positive and one negative. So you could try whichever one. You could try negative 3, positive 4, positive 3, negative 4. Can't make them both negative because that would give you a positive when you multiply. Now I am noticing that the middle term, when I add them, is a positive. So that's indicating to me that the bigger of the two numbers has to be positive. And if you don't see it right now, you can try it the other way. But it is going to make the bigger of the two numbers positive. So I'm going to go ahead and put a positive for the 4, a negative 3, a negative 2, and a negative 1. Keep the bigger one positive. Add them up. Negative 3 plus 4 gives me positive 1. 6 plus negative 2 gives me 4. 12 plus negative 1 gives me 11. Okay, notice the 4 is that middle option. 6 and negative 2, that means I have a 6. And order does not matter, by the way. You just need to make sure you put a negative right here and a positive right there to match up with my signs that I have right there. So my final answer is right there, k plus 6, k minus 2. Go back and multiply those two, and you should end up with the problem you started with in number 3. I threw 5 on here because it certainly looks a little different than the others. So what do we have going on in 5? Well, we're essentially missing a term. If it makes you feel better, you can do this. We can put plus 0 at the end. That's certainly an option. Okay, and I saw a lot of people that were doing this and went ahead and did the exact same thing, x and x, to give me x squared at the beginning. And they said, how do I multiply to get 0, but add to get a negative 8? And I don't know about you, that confuses me. Okay, I know anything times 0 is 0. So I'm just going to, on a whim, put an 8 here because I know I need negative 8. 8, I'm going to put a negative with it, and then I'm going to put a 0 here. Doesn't matter positive or negative. And what we have there actually works. Okay, there's nothing wrong with what we have there. Because if you do multiply the middle two terms, and I'm going to check this, I get a negative 8x and a plus a 0x, which gives me my negative 8x right here that I need to get. And of course, negative 8 times 0 does give me a 0 at the end. Okay, I personally think that makes it more confusing. I'm going to leave that there. I'm going to come back to it. But I'm going to offer a different way of looking at that. And just a good habit to get into. When you're factoring, you should really check and see if you can pull anything out at the beginning of your problem, if you can pull anything out of the 2 or 3 terms or 4 terms, however many you're given. It's called common factoring by a lot of people. Find the greatest common factor. So in this particular problem, just clean things up a little bit here. I'm going to get rid of that 0 because I really don't need it. Let's move this over. We'll come back to that. All I'm going to do right here is I'm going to notice that both terms have at least one x. Okay, the first one has 2 x's, x times x. So I can actually factor out an x. And now I'm really undistributing. That's it. In my parentheses, what do I multiply by x to get x squared? And that's going to be x. X times x gives me this x squared right here. Now, what do I multiply times x to get negative 8x, my second term? And that should be a minus 8. Double check. X times x, x squared. X times negative 8, negative 8x, which is the problem that I started with. Now, if you look at our 2 answers that we just got, aren't they actually the same thing? This one looks a little bit different. Do I really need the plus 0? X plus 0 is the same as x. Let's get rid of the plus 0. Really don't need the parentheses now, so I guess I can't really physically move it. I really just have x times quantity x minus 8. And it doesn't matter if the x is at the beginning or at the end. Usually we like to put it at the beginning. It means the same thing. Okay, work through some others, but those are some basic problems. Notice that in all of those you had a coefficient of 1 for your highest power term. That would be the variable squared, whatever variable it was. Okay, watch the next video if you need help with the other problems where you do not have a coefficient of 1.